oil and gas industry Gulf-wide, not just those that were on the Deepwater Horizon. So this is part of the natural resilience of the Gulf of Mexico. There's over 1,000 natural seeps that occur within the Gulf of Mexico. This has been known for over 100 years. The first publication was in 1910 in Scientific American that showed a very similar map to this one. This one, of course, is a Google kind of satellite image, but the one in 1910 showed these same places as having floating oil in the Gulf of Mexico. Now we've pinpointed many of those, and this is to the tune of a release of about 1 million barrels a year. That's about the size of a super tanker each year that slowly seeps into the Gulf of Mexico. And so the good side of that is that the Gulf of Mexico is inoculated with a huge flora of microbes that feed upon oil and gas. I'll get more to that in a moment. The picture on the bottom right is out of the National Academy of Sciences that shows kind of the distribution of oil in the sea in the North American waters, and you see that 62% is from natural seeps. Others are consumption, transportation, and extraction shown in that. That was during the period, the decade of 1990 to 99. Let me show you a couple of examples of these seeps. These may appear to you as kind of boulders or cobbles on the bottom. They're in fact on the deep slope below the Flower Garden National Marine Sanctuary. It's a coral reef area in the northwestern Gulf of Mexico. These are quite deep, 950 meters. It's off the continental slope, and it looks like a series of boulders. And it surprised the video guys when they first saw this from an ROV. They collected them, brought them up to the deck, and as they warmed on the deck, a guy took a knife and sliced into one of them, and then it looks like your favorite chocolate dessert in the restaurant with that warm center coming out of it. But in fact, these were all tar balls laying there on the bottom. Here's two other examples of evidence from the Gulf of Mexico. On the bottom left, Ian McDonald, back in the 80s at first and then further into the 90s, doing lots of studies on these natural seeps, found the gas hydrates, and that dome you see there is actually where the gas comes out and actually freezes right on the surface of the substrate of the bottom. And then you see the methanotrophic or chemotrophic organisms that actually are living off of that methane gas that's coming out of there. So that's kind of a dome of methane gas. If you brought a chunk of that up and laid it on the deck of the ship, it looked like a piece of blue ice, but you could light it with a match and it would burn because it is methane gas. On the right is a satellite image. You see the little plumes here. Those are all seeps coming up from the bottom, probably 4 different ones strung there, some here, more down here. They're able to use techniques now to use physical oceanography and calculations to go down to the bottom to figure out where these are. And in fact, just a few years ago, a team of Mexican scientists and U.S. scientists went on a German research vessel to the Bay of Campeche, which is in the southern part of the Gulf of Mexico. And the video image from the ROV showed this, and it looked like volcanic rock. But in fact, when they brought chunks of it up, it was asphalt. And so these are large asphalt flows on the very bottom of the Gulf of Mexico in the Bay of Campeche. And you see some tube worms that are growing off the edge of these things. So this is kind of the story of the importance and this resilience that the Gulf of Mexico has. And it's probably one of the most resilient in the world for oil and gas activities because of the millions of years of natural seeps and all of the microbes that live there and are able to feed upon it. Now, I'm not saying that if an oil spill occurs from a tanker or from a blowout that they're just going to eat it all up and it's gone. It's 2 different kinds of spills that we talk about. A chronic spill is one that's very slow, usually over a widespread area, and the microbes can take care of that. They can work on the larger acute spill, but it takes a long time for that to take place. They did in this case, in the study by Kessler, the microbes removed hundreds of thousands of tons of methane during this process. They even were able to, in their sampling, show that the plume, that underwater plume that I showed you earlier, was drifting off to the southwest. The currents then were circling at some levels and bringing the plume back around to the well site where the fresh methane was coming out, and it in fact was already inoculated with microbes that were expanding in size and numbers, And so they got right back into the plume and started feeding on and breaking it down. So it was kind of a process of circling and moving the microbes around and helping with that breakdown process. So it was really an important or key part of the breakdown that was taking place. This is a really nice map that was prepared by National Geographic in October of 2010. If you didn't see that article, if you have access to National Geographic, I'd encourage you to look at it. It's about a 20 or 30 page article. And this map put out for the first time where all of the shallow coral reefs, those are the open circles you see, the deep corals, not necessarily reefs, but deep corals, some of them are in like reef structures, and then the cold water seeps or the black circles. And you can see that the Macondo well was right in the area of a great abundance of those, and there's considerable study that's currently going on related to those. Some have been shown right adjacent to the well blowout area to the corals have been impacted by it. Others nearby have not, but it's currently an ongoing part of the study that's taking place. I studied the Eekstock spill back in 1979 and 80. The Eekstock spill that most people had forgotten about until the Deepwater Horizon came along occurred in a similar kind of distance offshore to the Deepwater Horizon up here, but it was in shallow water, only 50 meters instead of 1,500 meters. And the oil primarily moved along the currents to the west and then to the north, carrying it all the way up to Texas. The red line that you see is the area that was covered by oil on the shoreline during that spill because it blew for almost 10 months as opposed to only 3 months up here, and fortunately very calm seas at that time. So an interesting comparison from a previous spill in the Gulf. So maintaining a robust resilience is really key to the sustainable future of the Gulf of Mexico. All of these aspects I've been talking about and others here, the biodiversity, kind of the adaptive biota idea that Mike was talking about, and very diverse habitats. But how much can we stretch it? How far can we stretch that resilience? The concern is that it's not just this oil spill that came along for the Gulf of Mexico, but there's lots of other issues that have been out there. Is that a 1?
That's a 5.
Ooh.
Or
Okay.
it should be a 1.
Okay. I'm near the end. The Gulf is this healthy and productive ecosystem, but we've got a lot of challenges there. And these other things that I see listed here, you see listed here, most of you know these from other places in the world also, and they've been going on for 50 or 60 years in the Gulf of Mexico. And all cumulatively, all told, these are much more of an impact on the Gulf of Mexico than the Deepwater Horizon spill was. So back to my little analogies a while ago, the Gulf is also sometimes considered as its water filter, but also its disposal. If you look at the map on the left, that's the drainage area from the U.S. and Mexico into the Gulf. And then the one on the right is the hypoxic area that most of the world knows about, one of the most famous deadwater zones in the Gulf of Mexico. But the silver lining, as I wrap up here with this spill, is the fact that it brought a lot of focus and attention to the Gulf of Mexico. It brought more research dollars to the Gulf of Mexico than we've ever seen before. BP put up $500 million, $50 million a year for the next 10 years to study the Gulf, and that's ongoing now. Some really important research that we'll learn more about this spill than probably any ever in the world. And then thirdly is the restoration that's going to take place. The Restore Act was passed in the United States a few months ago, and it guarantees that over 80% of the funding from the fines that will come out of this will come to the Gulf of Mexico for restoring the Gulf and get to some of those other issues that are related also. So this map shows some of the topographic highs that we've been working on with teams all around the Gulf in the U.S., Mexico, and Cuba to set aside a network of marine protected areas. These hugely important areas, very diverse and important for conservation and fisheries and biodiversity in the future of the Gulf. And lastly, one of the things that the Hart Institute is working on is developing a report card so that we can determine then how, or with a metric that we can determine how the Gulf is recovering and measure that as time moves along. Thank you.
Thanks, Wes. Very good. Just quickly, really interesting from a resilience perspective, 2 points that I picked up there. One is the bacteria in the system, subsystems within the system. The other one is the entire Mississippi drainage, much larger system within which the Gulf of Mexico is operating. Okay. Questions? Questions for clarification?
Yes, Karen.
Excellent. Can you come and speak on the mic? Is this session being recorded?
Pardon, sir?
Is this session being recorded?
Yeah, sure.
Okay, so we need to use the mic so people can.
Okay.
Let's make
Can
this quick.
can I have that?
Yeah, sure.
Here it is.
Mike, maybe you should explain, we're going to have questions and answers at the end too, so not to
Yeah.
make these very long.
Yeah, just.
Okay, quick
just-
question then. So the microbes is really interesting. My understanding was that that was the, wasn't that the solution that was used finally, was microbes that were injected to clear up the oil spill, or how was oil spill cleared up?
No, that is a cleanup technique. There are some really interesting, even patents we were talking about on microbes that have been used in other places in the world, but that's not used in the U.S. anymore. Typically, nutrients are added now in places to speed up the process of the microbes that are there. I would point out too that warm water areas are better for the breakdown, both biological, chemical, and physical breakdown or weathering of oil than cold water areas. In cold water areas, some oil that was spilled 30 years ago, you can go find it just like it was when it was spilled. So it really makes a difference whether you're talking cold water or warm water.
Thank you.
Right. One more question quickly before we go on to the next. Yes, sir.
Thank you. My name is Jong Ban-jung from Korea. I would like to ask a question. In the case of my oil spill cleanup, just 5 years ago, along our Korean peninsula, we have Pearl Bay spirit oil spills occurred in my province. At the time, I also joined the cleanup response at that place, and I would like to ask some question. Which one is more preferable, like as engineering systems response, and another one is naturally recovered oil spill cleanup system. So I would like which one is the threshold to take the engineering system, and another one is naturally recovered system. Then which one, in this case, I don't know the exact level of the recovered the environmental status. The first stage is engineering system, and second stage is naturally recovered system. At the time, how can we determine the cleanup systems completed? Then can you give me some comment on that, the desirable level of that recovered ecosystems?
Yes, there's a system that's used worldwide now called the Environmental Sensitivity Index. And the Environmental Sensitivity Index is a contingency planning tool where you look at on a scale of 1 to 10 all the different kinds of environments. The ones that are least affected and easiest to clean up and recover are the rocky shores, bare rocks, and going to a number 10, which is the hardest to clean up and the longest time to recover, and those are the marshes and the mangroves. And so there are engineering tools that are used in certain ones of these places to help in recovery and cleanup. But in some places, like the mangroves and the marshes, you don't clean them up because the cleanup techniques, the engineering, can be worse on the environment than the oil spill itself. So it's a complicated system, but that's the tool that's used in many, many countries.
All right. Thanks very much, Wes. Right, next, Ibrahim. Ibrahim Chio, is that correct? Did I get it right?
That's something like that.
Something like that. Okay, you can put me right.
Thank you. My presentation will be on the same topic, but it will be very different.
Introduce yourself, please.
Yes. It will be very different because I'm talking about a situation which has taken a longer period of time, but also because the speakers are different. He was a very eloquent speaker, very good English. I have to struggle with my English because I translate into 3 languages because it gets to English from my original language. My name is Ibrahim Chow. I work for the United Nations Environment Programme. I'm the head of the division in charge of ecosystems and disasters and conflicts, amongst other things. And this presentation was actually prepared by one of my colleagues who could not be here, so I'm sort of stepping in for him. Murali, who has been working on this situation in Nigeria with other colleagues. And so therefore I will speak on his behalf. It's about Nigeria, West Africa, the southern part of Nigeria. The Ogoni land, as they call it, is more or less 1,000 square kilometers, has 4 local governments, and has been producing oil between the 60s and early 90s. It's a region which is also like the Gulf of Mexico, but maybe a little bit less, has a lot of pipelines going through it, large wetlands, mangroves in general, and that the pollution that we have observed in the region has now been widespread. Air pollution, water pollution, and any pollution you have in one place can actually migrate to another place because of the complexity of the takes and so forth. As I said, the operation started in the early 60s. They were stopped more or less in the 90s. The analysis, therefore, covers a long period of time. Basically, some spills occurred 40, 50 years ago, and we have to look at the consequences of that. And we will go through the report itself so that you see the difference between this situation in Nigeria and the accident that was that occurred in the Gulf of Mexico. These are situations that you should normally not observe, where you have actually, people occupying ways of right of ways and living next to pipelines, and these are also situations that normally you should not observe, but you now see very clearly in Nigeria. Key observations, and I have a series of slides on the key observations. The team that we sent there went to examine all the oil spills that are known or that they knew existed or they were informed about in the Ogoni land only, which is only a portion of the Niger Delta as a whole. Also that I think needs to be clarified. 67 sites were observed. 41 of these sites have pollution level exceeding the Nigerian intervention values. In 38 of these sites, pollution has migrated to 1 meter below ground. Again, I'll come back to how deep it can go. In some places, the pollution has gone down to more than 5 meters. In no spill sites, the target value has been achieved in terms of, again, looking at the regulation in Nigeria. However, 2.5 million cubic meters of soil have exceeded the target value. Again, this is just kind of the observations that we have seen there. If you look at the picture, I think you can observe the kind of situation you should not see, or maybe the picture is not clear enough for you, but it's basically pollution everywhere. One of the observations is that there is no confining layers of clay anywhere in the Ogoni land. That's, I think, a fundamental observation that I will also come back to, because there were some assumptions there that actually the study proved that they were not absolutely correct. What does it mean? It means that the pollution can reach very deep into the the soil and contaminate drinking water. The study also observed that there are very high concentration of benzene in some places, and this is a serious health issue, especially next to one of the oil industries, the local industry, the national company. In 5 community wells, the team has come up with measurements of benzene that are exceeding by hundreds of times. In one village, it was 900 times over the World Health Organization's norms, which poses a serious threat to the community that have been drinking that water. Just some pictures that you know some of the right-of-ways and some explosions there. Again, I think you can clearly see here the pollution. The exposure to hydrocarbon is quite widespread. Air, drinking water, bathing, swimming, walking, it's basically part of the life now in many places there. As I said, the concentration of benzene is very, very high, and that really was one of the most difficult issues that the team came up with, was to be very careful in informing the government and the local authorities that these concentrations